Hello again. We're working with sine graphs, and basically what we're going to do is we're going to manipulate amplitude, period, phase shift, and vertical shift. We did each one individually. Well, this time we're going to work with all of them. And basically what I did was I drew my y equals sine of theta graph or sine of x, and here it is. It's a general graph. It's just drawn as best as possible, but you know, you do what you can do. And the period of it is 2 pi and the amplitude is 1. That's just a given with a basic sine graph. Well, what does that have to do with anything? Well, I want to try to figure out what the amplitude, period, vertical shift, and vertical shift and phase shift are of this graph, and maybe even if I'm ambitious, I can go ahead and try to graph it. And let me just say this right now, when I give this problem to students, most students just plug it into their calculator. It's a very difficult problem. It is challenging. I do expect that students can figure out all 4 of the components of this graph, but graphing itself can be a little difficult. I'll show you what I would do. And I'm not going to use a table either, because I don't think that you should have to once you feel confident enough to be able to do it. But if you want to use a graphing calculator, that's fine too. So here we go. I want to figure out the period of this graph. Well, the period of this graph, of all sine graphs, is 2 pi over the number in front of theta. Well, the number in front of theta in this case is 2. So it's 2 pi over 2, so the period is pi. Which basically means that this graph is going to be, compressed like an accordion. It's going to be half as long, or take half as long to repeat itself. The amplitude in this case, which I will just signify with a and p, is the number that's being multiplied in front of the sine function. Well, the number being multiplied in front of the sine is 3, so the amplitude is 3. It doesn't mean that its highest and lowest point are 3. It means that its highest and lowest point from the midpoint of the graph, and in this case the midpoint is at the x-axis. But actually sometimes the midpoint can be midline, could be right here. It'd be 3 away from the midline. And I went ahead and I drew that because I could just look at that right now and tell. The phase shift, we'll do phase shift. Yeah, I'll use colons because I did the same thing there. The phase shift is the opposite of this number. Well, the opposite of negative pi is pi divided by the number in front of theta. And the number in front of theta is 2. Oh, that was easy. Okay, just pi over 2. It means that it shifted pi over 2 this way. Each line here stands for pi over 4, so it's going to be shifted 90 degrees. This one's 45, 45, so that's 90. That's how it gets shifted. And the vertical shift of this graph is what you're adding or subtracting. If you're adding, you're shifting it up. If you're subtracting, you're shifting it down. Well, you're adding 1, so the vertical shift is 1. So that's usually where students kind of stop. They say, oh, okay, do this, and they answer it, then they go ahead and they put it in their graphing calculator, and then they graph what it looks like in their graphing calculator, saying, oh yeah, I did this by hand. Most of the time they don't. Sometimes some people do. So here we go. When it comes to level of importance, if you want to go ahead and graph this, I would say account for both shifts before you even look at amplitude or period. Actually, I think period should be 3rd and amplitude should be 4th. So I would do 1st, 2nd, 3rd, 4th, if I were to pick an order. So the phase shift is pi over 2, which means I'm going to shift it over, I'm going to take this point and I'm going to shift it over pi over 2, or 90 degrees. Well, this is 45 degrees, that's 90 degrees. So my starting point's right here. No, it's not. That's your phase shift, your horizontal shift. Now you got to worry about your vertical shift, and your vertical shift is 1. So you shift it over here and you shift it up 1. So this point is actually right there. Oh, okay. So now I can just draw it like, no, you could if the period and the amplitude were, 2 pi and 1. Then you could just copy this graph except, extend it. But since the period is pi, it means that it takes half as long to develop. Basically what that means is that each one's 45 degrees, pi is 180 degrees, so 45, 90, 135, 180. It means that this graph will repeat, it'll look something like this. 1, 2, 3, 4, right here. Okay? I don't know all the exact values. I mean, I guess I can compute it if I made a table really quickly, but I do know this. And you can go ahead and check it out if you want to. It's pretty cool. What is really interesting about this graph is the sine graph will repeat like this. It's going up here, it'll go up here. But it's going to have to go down. Now, students ask, well, where does it go down? I said, well, that's a pretty interesting question. If I drew this xy axis, perfectly, which I didn't, but as well as I could, I know that's going to go like this and go like this. Well, that means that it's probably, well, not probably, it is going to go down. It's going to hit this part again right in the middle. Well, can you figure out where right in the middle is? And you're like, if I go 1 here and 1 here, that's there. So I know it's going to look like that. Yes, that's really cool. So the graph's going to look like this. But I say you can take it a step further if you wanted to. People say, well, what do you mean? And I say, well, you know that it's going to have a high point and a low point, and its amplitude is 3. I say, oh, that's easy. So it's going to be at 3 and at -3. No, no, no. The amplitude means how high or low it is from its midline. This is its midline right here. So it's got to be 3 up from here and 3 down from here. Now, here we go. It's got to go up and go back down. Where's it going to hit its highest point? And you're like, oh, won't it hit its highest point in the middle of this? And you're like, yeah, it will. And it'll hit at 4, because it'll be 1 plus the amplitude of 3. And here it's got to go down. It's going to hit its lowest point. Well, go 3 down from here. 1, 2, 3. It's like right there. You're like, oh. So it's going to be like, no, it's not like a straight line. It's like this, except it's, you know, compressed like an accordion and kind of stretched out. Actually, you could figure out what this is. This is pi over 4, 2 pi over 4, 3 pi over 4. So it's going to be pi over 8. It's going to be somewhere like right here. I don't know where. Let's see, 1, 2, 3, 4, 5 pi over 8. So 5 pi over 8 would be in the middle of these two. So if I plug in 5 pi over 8, this is going to be pretty fast computation. So if you don't feel bad. 2 times 5 pi over 8 is 10 pi over 8. 10 pi over 8 is 5 pi over 4. 5 pi over 4 is 225 degrees. 225 degrees minus 180 degrees is 45 degrees. So the sine of 45 degrees is root 2 over 2. Root 2 over 2 is about 0.707. You can check that in a calculator if you want to. 0.707 times 3, I don't know exactly, but it's like 2.1. I'm just taking 0.7 times 3. 2.1, it's probably more like 2.2. Let's go 2.1. 2.1 plus 1 is about 3.1. So if I really did kind of want to figure it out, it'd be like right there. So it kind of goes like that. But that's not really important. What is important is that you got a general outline of what your graph looks like. Didn't use a graphing calculator, didn't use a table, we're just given the period, amplitude, phase shift, and vertical shift, and you can figure out a very complex problem. In all honesty, most students just plug it into their graphing calculator. And the graph does repeat over and over and over again. One last thing that I want to talk about, the graph, the domain for this graph goes from negative infinity to infinity. I can plug in any theta value I want. The range goes from the lowest value, which is negative 2, to the highest value, which is 4. That's pretty much all I ever do when I do this. I already answered that. Now in this case, the domain is from, on the red graph, negative infinity to positive infinity, but the range is only from -1 to +1. This is an ambitious lesson, difficult. It's not very easy for students. But if you were able to keep up, that's great. With that said, have a good day for now. Goodbye.